next session while folks are getting on board. This session is called Custom Data Architecture and Analysis Tools for Vision Zero Action Plans. WSP and local government technology startup mySidewalk were selected to assist in the development of a regional safety data system and state of safety in the region transportation technical report for the Bay Area Metro Transportation Commission. This custom built tool and technical report go beyond traditional GIS and business intelligence approaches to offer data reports and resources for custom drawn boundaries. This session will highlight processes and techniques that all attendees can use regardless of their choice of software tool or partner. And I'll introduce Josh Bain. He's an urban planner and data analyst from Kansas City working at WSP, where he helps clients make better decisions about infrastructure priorities using data. Prior to WSP, he worked for government technology startup mySidewalk as a solution architect, Jackson County, Missouri as the development manager for the Rock Island Trail, and BNIM as a consultant planner. Josh lives car-free in downtown Kansas City and is interested in reducing automobile dependency and creating safer streets for all road users. Josh, I'll turn it over to you.
Great. Like Lisa said, my name's Josh. I'm really excited to be sharing this project with you. It's something that we've been working on for the last couple of years. I would not describe myself as a safety expert. So if you really want to stump me, ask me a tough safety question. So I've got a little bit of imposter syndrome here talking about safety, but I love the use of data to make better decisions. And so I'm going to present today a little bit about the Bay Area context. This is about the Bay Area, but I think the lessons learned here are very relevant if you're working on a similar data project. We'll talk a little bit about the project goals. Through this, we developed user stories and personas for those user stories. So we figured we thought a little bit more about who's going to be using this tool. And so I'll talk a little bit about that process. I'll talk about the data architecture and some of the unique things there. And then we'll do a little demo of the system. So hopefully we can fit all of that into 30 minutes. So a little bit about the Bay Area context. It's a very large, diverse area. It's, I would say it's about 8 million people, 7.8 million people. So if you're thinking of like the size of Missouri and Kansas combined, or it's about 9 million people. So it's a little bit smaller than the population there. But it's 9 counties, three different metropolitan areas actually intersect with the MPO boundary here. There are about 101 cities, and it serves rural to very dense urban areas. And so if, maybe if you're from the Kansas City area, this is starting to sound a little bit familiar. Maybe you're thinking, well, at least they don't have a state line to deal with like we do here in Kansas City. But it is a very large area and has lots of very divergent safety needs. And, kind of contributing to my imposter syndrome here is that, the folks in the Bay Area, especially in San Francisco, Oakland, other communities, they were really early adopters of Vision Zero, this notion that nobody should die or be seriously injured as a result of the way they get to and from work. And so I think Vision Zero goes back to 1997. They adopted it in 2014. I don't know about you. I don't know if I even knew the term Vision Zero in 2014. Maybe I had heard it once or twice, but it was very new in the US at the time. And they were early adopters there. And then, in addition to all that, they had really sophisticated tools, staff and advocates, people who knew stuff about safety and were very involved in these conversations. They've got a great web mapping app. All their crash records are available for query online through a system that UC Berkeley developed called TIMS. Several of the large cities have developed their own dashboards, and even in cities like San Francisco, I think this is the only city in the US to do it. They've linked their epidemiological data, trauma center data, with law enforcement records. So many of you know this, but our source of crash data is law enforcement records, and that can sometimes be flawed or undercount the true number of crashes, especially for vulnerable road users. And so San Francisco's actually gone farther, and they've linked that data together. And so, they've got this, they're highly sophisticated, and here I am, this Midwesterner, in a very different context, trying to figure out what we can contribute to the problem here. And so we we started to look at the crash trends and found that in spite of all of this, they're still experiencing these stubbornly high crash levels. If you look at this chart here, you see that there's a 48% increase over their 2010 levels compared to about a 17.6% increase nationwide. And what's growing that share, if you look at the share of fatalities that were non-motorized in 25% in 2005, there were about 25% of them were non-motorized, and in 2020 that share has grown to 33%. And so this might sound a lot like the national trends that you're used to seeing. Some of the things that you've seen here is where maybe we've made some success and gains in the traffic safety world for motorized users, that those gains have not translated to non-motorized users. And the more urbanized you are, the more exposure you have to bikes and pedestrians. And so this is really a challenging problem. So enter our client, the Metropolitan Planning Organization of the Bay Area, MTC. They, I think, decided to take more of a leadership role in safety in their region, recognizing that, yes, they have high capacity, very, very capable staff and political leadership in all of their, in many of their larger cities, and even in their county transportation authorities and county governments. But there's still a gap needed, and there was still a need for regional coordination. And so they kind of entered into this conversation, and in 2020 adopted their own Vision Zero policy, and said that they were going to help in a couple of ways. They were going to provide data and data resources for the cities in the Bay Area. They said that they were going to advocate and suggest policy initiatives and legislation. And then they said they were going to focus on education and engagement of the people who have the power to actually make changes to roadway design that will lead to safer streets for everyone. And they've actually done a lot of that. So they formed a Vision Zero working group in 2020, and a subset of that, a data committee, to really focus in on data. They actually helped to change state laws. In California, there was there's a law with a lot of perverse outcomes that required local entities to set speed limits based on the 85th percentile rule, which is not good if you want to make streets safer. And then, through kind of a long procurement process, ended up hiring mySidewalk and WSP to work on this data tool project. And so that's what I'm going to talk a little bit about now. So you see here this kind of crazy diagram showing all of the moving pieces of our deliverables as a consultant team and a software team. I started this when I was at mySidewalk. We got the RFQ and we read it. We thought, yeah, this is right up our alley. And then we realized how much technical safety expertise was required here. And so I just happened to see a local engineer talk about safety at a Planning Sustainable Places meeting, and he took a group of people who were very opposed to a project, and he calmly and passionately explained, the reason that we need road diets and the reason that we need traffic calming and bike lanes and that sort of thing, and turned an angry crowd into a convinced crowd. And so I thought, okay, I want to partner with this guy. So that was Jay Aber at WSP, and they agreed, and we were ultimately awarded this contract. And WSP is really focused in on the, I would say, the technical consultative work, but that work relies on the data resources that mySidewalk was creating. So a relational database that we were creating that powered a dashboard generation tool, and that also powered a separate unique query environment that you can use to do more advanced crash queries. And so you can see on the left there, just sort of some of the listing of sources, the base map inputs that we were using, all injury level crashes. We excluded property damage only crashes, some equity data, point of interest data, roadway characteristics data, bike infrastructure, sidewalk and crosswalk data, which we purchased from a vendor through our contract, and then some speed data, speed limits from the Federal Highways HPMS data source, and then INRIX data to get actual observed speeds on certain streets. So all of this got combined into a single relational database and powers the data tool that we're going to show you here. But I think more important than what we're building is who we're building it for. And so we thought about who's going to use this tool, and what do they need. And so we kind of thought about, like, what are the the steps involved in making any plan, whether it's a local road safety plan, a Vision Zero action plan, a strategic plan or comprehensive plan. What does that process look like? Well, typically it starts with collecting data and defining goals, analyzing data, developing your plan, doing project and policy development, and then measuring your outcomes. And then we thought about on the other axis on this table, who's involved in making those decisions, who's involved in that work. Data is collected largely by law enforcement officers, but planners are really the ones who are doing the work and analyzing the data, developing a plan, identifying projects, and sometimes even recommending priorities for those projects. But they have support from all of these other fields as well. But you can see that the planners, engineers, safety professionals are really, really critical to this work. And so they were kind of our central persona. And so for each of these, I'm just going to show you one of them, but for each of these, we did a kind of a persona worksheet where we described the role, we did interviews with them, we researched their role. Some of it was easy. I'm a planner, so I know what planners do, and that's fine. But I don't necessarily know everything about law enforcement and the things that they do related to crash safety. And so these interviews and this research was really important. And then we kind of figured out what their strengths and weaknesses were, what their challenges were, and then how a software tool could help if a software tool could help. And for planners, really their key challenges are, they've got decent skills in data analysis. They know enough about traffic safety. Maybe they're not as savvy in some of the engineering and design principles around safety, but they're really, really skilled in planning, policy, and public development. The challenge for them, though, is that they are they're having to translate these technical concepts, which maybe they understand, to people who don't have as much time or energy or education to be able to understand them. And then they also usually they're not the final decision maker in anything. So they have to be a little bit persuasive, but also fair in the way that they communicate. And so this is a tool that hopefully does that using data. I'll talk a little bit about the data architecture. We kind of the magic of the system is that we abstracted geometry from the tool to a certain extent. So each the relationships are sort of built spatially one time, but then you're querying things based off of a text ID, and so each crash has a segment and optionally an intersection that it's associated with, and that crash and that segment ID live in its own table, and that's separate from data on the actual segment characteristics or intersection characteristics. I'll actually kind of show this entity relationship diagram showing all of the, this is not all of the tables, it's only a handful of them actually, but a handful of the different tables and fields and how they relate to one another. I think in the safety world, oftentimes we want a single table, we want an Excel sheet that we can turn into a pivot table and, tell me, I just want a summary of KSI crashes and then a bunch of fields for roadway attributes, and then I'll do a pivot table based off of that. And that can be useful to a certain extent, but if you want to dive deeper into a crash, you need to preserve the original tables and to build relationships between those tables. And so that's what we've really done here. In terms of roadway attributes, we looked at a number of different sources. I mentioned them earlier, but the number of lanes, speed limits. We looked at off-peak average speeds as sort of like a kind of a judge for how fast people were actually going in the area. The presence or absence of a sidewalk. We didn't have condition data or width data, but we did have presence, and we thought that was important. Bike infrastructure, data on equity, and a whole bunch of other stuff that's not here. And so this all looks great, but then when you start to actually look at the network itself, and maybe you can kind of see this on my screen, but these are, that doesn't really matter, but these green lines are bike facilities, right? And the black lines are the underlying base map network that we had. And as you zoom in, you see like you've got just a slight difference in the geometry here. And so being able to, what we really want is for this segment here, we want an attribute that says this is a class 4 in California called a class 4 protected bike lane. And that's what we're trying to associate with this, but that's a very actually pretty challenging task. And so a couple different ways that we had to do that. We used open source GIS tools and some just basic spatial logic, some buffers and overlaps and selection tools there. That got us a long way. But some of ArcGIS's conflation tools and base map tools actually got us a lot further. And so that was a huge help in building the system. There's in any process or project, there's going to be manual data correction. And then ultimately, you know, you didn't, I guess you did hear it from me, but there's got to be some acceptance of some error, you know, in an area that's 7,000 square miles of 28,000 centerline miles of roadway, that there will be some error that's just going to have to average out or be accepted throughout the region. And so that's how we overcame that challenge. And then, you know, we WSP, I will say, and this is not a pretty graphic by any means, but we use the data system to develop some crash trees. And you can kind of see, this is one of 4 trees that we developed. This is motor vehicle segment crashes. And, you know, and crash trees are sort of dividing up different attributes. And we were looking at sort of representation ratio is the word that we use, but essentially if a type of segment has 10% of the crashes, but it's only 5% of the length, then it has a representation ratio of 2. And that means that those attributes and those characteristics were unsafe. And what we found in doing this is, even as we were controlling for volumes, the width of the road and functional class, that certain attributes really stuck out. 4-lane undivided roads, this is probably going to be familiar in most places, were highly dangerous signalized intersections. And then if we were in an equity priority areas, they're environmental justice tracks essentially, or within more urban area types, we found elevated levels there as well. And so this is one of the consultant applications that was of the safety data system that was used here. But really what I want to show you, and we've got about 12 minutes, I'll try and keep it to 10 minutes. What I want to show you is the Bay Area Vision Zero system that mySidewalk developed. I helped develop it when I was there, but it's really their technology, a tool called Press, where they're creating custom drawing tools. And so I'll kind of walk through that demo. So this is Bavis. This is named by the client. I'm really proud of their name, but it stands for Bay Area Vision Zero System. And so BA, BI, and Z are capitalized in the acronym, if you're wondering. So there's a long description about how to actually use the tool. But you can see here this little interactive map widget helps you pan around the Bay Area. You've got some selection options here. You can do a multi-select. So I can select multiple census tracts, for example, or if I wanted to select a full city or census designated place, I could do that. There's a custom polygon drawing tool, which I'm not going to use. And then there's also a radius tool where you can pick a point of interest and select a custom area there. And then there's some map overlays. The map overlays don't do anything. They're just there to inform you about where you're at and some context there. So if you cared about equity priority areas within the Bay Area, these are their environmental justice tracks. Here's where those are located. If you cared about where there's transit, where there's childcare facilities, where there's health or other like medical like hospitals or outpatient facilities, you can find those. And then there's parks as well. These were all things that our data committee said were like, these are generators of pedestrian activity. You might think that there's more vulnerable road users. So we agreed with that and included them. And then there's high injury networks. We developed high injury networks for the entire area. We did, I think we did 4 of them, actually 5 if you include the highways. We did a highway version as well. Although this dashboard really doesn't focus on highways at all, since this is for local jurisdictions. This is all great context here. I'm just gonna walk through creating something right around downtown Berkeley. It's right near the college, a lot of pedestrian activity. You can see there's some high injury networks. And if we look at the biking and walking high injury networks, it looks like those modes are the most affected by traffic crashes here. But yeah, I'm gonna select that. And then I think I can change the radius here. It will be this new shape that I select. So it'll be about 2 miles around this intersection. And then I'm going to request a dashboard. I'll type in the name of the area of interest, and then my name, my email address, and my organization. I'm not actually going to type this in. I've kind of pre-baked this just like Julia Child has, but you know, once I fill out my information, I will get an email telling me that my dashboard is ready. It takes about a minute to produce. So a minute isn't that long, but in internet terms it is. And so we didn't want somebody to be waiting on a screen for a minute. It's doing calculations on the fly and producing, you know, probably 500 different data visualizations. And so that's why you get a link emailed to you later on. And that link will take you to a dashboard that'll explain a little bit more about your area of interest. And so I'll walk you through what that looks like. And these are all the same data visualizations, all the same sort of things, except they've changed. The thing that's going to change is the area of interest and the data that's relevant to that area of interest. And so you can see we've selected our AOI here. The first thing that you'll see is collision summary data. So these are all of the crash statistics. So you'll see an overview of that. If you zoom out, you'll see kind of a heat map. But then as you zoom in, you'll see in purple here the fatal crashes, red serious injury crashes, and then all other injury crashes are the small yellow dots. And you can start to see some patterns here. They look a lot like our high injury network, which is good. But you can see where those crashes are, and this is 10 years of data that here. Basically 10 years of data throughout the entire thing, except in certain cases where we'll mention it. And you can see really quick crash totals here: 232 in the small area, 232 fatal or serious injury crashes, and about 4,200 crashes, injury crashes involving any type of road user. In this particular area, about 70% of the KSI crashes were involving people who walk or bike, and only about half of the injury crashes. So bike ped crashes are a lot more severe here, and you can see a little bit more on the details of what different modes were in fact affected and how. And then you'll see different data on collision trends over the past 10 years. You can see that both motor vehicle and bike ped crashes are up, but in this particular area, bike ped crashes are a much greater concern. They peaked in 2019 with 38 KSI bicycle pedestrian crashes. In the same period, around 14 motor vehicle crashes. Again, right around a college, right in a downtown area, but clearly a need to make safer streets here. And then we calculated some comprehensive crash costs using the USDOT's number that the cost of a fatal crash, the cost of society of a crash is about, a fatal crash is about $10 million. And so we use that here. This is if you were putting together a RAISE grant or some other benefit cost information and you were talking about the crash reduction benefits of a tool, then these are the figures that you would use to help reduce that. But really it's a way for us to weight crashes by severity. So if you care more about people dying or being seriously injured than people that are only hurt a little bit, those are the crashes that you probably want to focus on, right? And then there's a lot more detail. I don't have time to go into all of that here, but all the contributing circumstances, comparisons with the region, you can see, within our area of interest, pedestrian crashes are 41%. They're only 22% in the Bay Area. That's useful information. Bicycle crashes are actually, they're the second most popular crash type here. Popular is not the right word, but they're the second most common crash type here. And that's actually unique from a lot of areas we've seen. Bike crashes are usually third or fourth. Usually it's broadside that are second order in the order there. So there's a bunch of data here, more data than most people care about, but we didn't want to leave information out, and we tried to create it in a hierarchy that you get the most important information first. The other cool part of this is that each area gets its own mini high injury network, and there's still a couple things that are changing about this. You'll see the original regional high injury networks here, but then you'll also see these small segments. These are the top 20% or 15% of crashes within this area of interest. And so if you thought that, hey, this regional high injury network really left out streets that I cared about, that maybe they weren't significant on a regional level, but they were significant at a local level, you'll get that here as well. Again, I'm kind of running short on time, and I want to leave time at the end for questions, but there's a ton of demographic information here that you can use to frame your outreach and engagement. As this plan does not, this is not a plan, this is not a finalized plan that you get. It's a toolkit that you get to make a Vision Zero action plan. And so there's a bunch of demographic information here about who lives here, what the daytime population looks like, who works here, whether or not it's in an urbanized or rural area, and then a bunch of information on equity. So all of the criteria that go into their environmental justice track selection are here, and that sort of thing. The other section that's neat is that we've brought in a lot of the roadway attribute data into this, and so you've got statistics that are sort of calculated here on the fly: the number of intersections, centerline miles of streets, the number of miles of sidewalks, the number of bike facilities, that sort of thing, and then some. This gets to some of the systemic analysis that we were doing, but we looked at the share of centerline miles by length of a network versus the share of KSI crashes on that that same attribute. And and so here you're sort of seeing this 37% of KSI crashes are on these other principal arterials, whereas they're only 13% of centerline miles. So somewhat useful information there, but that exists for all of these attributes, whether it's the number of lanes or whether the road is divided or undivided, what type of signalization the intersection has, and that sort of thing. So once you've got all this information, it's great, but sort of like, so what do I do with this? And so that's really where the part that I'm most excited about comes in, and it's the least technologically complicated. But we basically say, okay, here's what your next steps are. Develop a Vision Zero action plan, and here's how you do that. Here's how you engage the public. Here's how you plan countermeasures. And really, this tool is meant to help you with planning and prioritizing countermeasures. And so we'll kind of share with people, remind them that pedestrian crashes are really the top crash type here. That's not going to be the case everywhere. They might be broadside crashes in other areas. And then throughout all of these, you can see that there are different crash types. And if pedestrian is the most important crash type for you, you'll get a bunch of information on pedestrian crashes and what the appropriate countermeasures for pedestrian crashes are. So here, sidewalks and walkways, a leading pedestrian interval, crossings at signalized intersections, uncontrolled intersections. And then there's all this information about the countermeasure itself. So whether it's the Federal Highways proven countermeasures toolbox, or whether it's Caltrans official local road safety manual, sort of the information from that will link directly to that, so you can see all of the information about that particular countermeasure. Like I said, this doesn't do everything for you. You still need planners, you still need community engagement, you still need technical expertise and engineering judgment to make this work. But it's meant to be a tool that rather than just giving you a bunch of data, helps spur on a little bit of action and give you some next steps. And so I know that was really quick. I'll happy to follow up with anyone if they've got further questions.
Thank you, Josh. We have a few minutes for questions, so feel free to put them in the chat. Greg asked a question, but you answered it, so check. I have a question that from the beginning of your presentation is one thing that we are wanting to do at some point in Kansas is connect the trauma registry to the crash database. And I know that probably happened prior to you all being involved, but do you have any sense of how that occurred or what the kind of heavy lifting of that is?
Yeah, so yeah, definitely was not involved in that. That was, I think, a Herculean effort. It's easier in San Francisco because their health department owns the hospital, and so there aren't many publicly owned. I mean, that's a pretty rare thing, and so the city of San Francisco owns the hospital, and their public health department was able to use that data within the organization, so they didn't have the same issues or constraints with something like HIPAA, where anything where you're going to potentially reveal personal health information is sort of a challenge. And so we actually didn't get to use that data, and it was just for one city. And so it's something that it would be the gold standard, and it's something that I think there's a huge need for here. The thing that that I think you can do in just about any state is look at the state injury database that exists just about everywhere in the state mortality database, and you can get demographic cuts of that data. You can get it sometimes at the county level to get an estimated rate for a demographic cut or something like that, or for a particular county. And then you can compare that to the law enforcement records and say, okay, well, we're about 10% short here. What's going on? And so I think that's a really good first step, but I think there's just a lot of administrative and legal challenges to doing some of that work. I would love to see it happen in the Kansas City area. We've got Truman Hospital as a publicly owned hospital, but it's a good question. Or maybe the state of Kansas can do it as well. And doing it for a distinct geography is a lot easier than doing it for the entire country. And so maybe starting with Kansas would be a great place to start.
Awesome. We need to move on to our next session, but I do want to get first, Greg York wants to know if we can get a link to the dashboard. Oh, and then you answered it took about a year to create. Well, Josh, thank you so much. Josh Boehm, thank you for starting off our morning. This has been really great and really good learning for us in Kansas, because we're looking to do a lot of this stuff. And
Right.
He's put a link in the chat. And so we're going to move on to our next session, but thank you, Josh. Thank you so much.
Great. Thanks. I'll see you all on the next one.